All right, John, today we're going to talk about frames. So we got a couple points that I want to share. I got a couple points on the board here. When we're dealing with frames, we're dealing with, again, if we think of that right-hand rule, we're thinking of individual planes, each one having an axis 90 degrees from each other. So we have the Z, of course, going up and down, looking at the right-hand rule. We have the X going left and right, and the Y going forward and backwards, just as we do in the robot. So when dealing with frames, we have a couple of different aspects we're looking at. The different types of frames. We have the world frame. Of course, that is a frame the robot's associated with. Being the center of the robot, the very base of it is the origin of the world frame. The tool frame is a frame that we put at the end of the arm tooling. It is the point that we choose. It's a position that we use to develop robot programs to allow us to pick in place or weld or do multiple things there. We'll be getting into that further here in a minute. And user frame. User frame is where we take and we develop a plane in space. We use that plane to develop a location for us to operate. So say our robot will come in and we pick a different plane anywhere in space, we can just, our robot program will adjust to that space. So it keeps things pretty easy for the programmer. The last two here are jog frame and cell frame. Jog frame, not used a whole lot, but again, it's to help to aid the programmer in developing programs to associate the robot position not to the fixture, not to the end of arm tooling, but to the parts themselves. So starting with world frame, as I mentioned earlier, world frame is considered to be the basis of the robot, or the frame that it operates within. As you can see, it's the core, the origin of it is at the core. Following again that X, that right-hand rule, the Y plus is shooting straight forward, X is left and right, and Z plus is up and down. This frame cannot be changed by the user, as I got noted here. So this is something that's, again, defined by the robot. We use that when you purchase the robot. It comes with that predefined. It's the basis, again, as mentioned before, of all the top positions. The center line of the robot again, and then this portion never changes. Next piece of this I want to share is the tool frame. The tool frame, as you can see here, it's a parallel operation of the world frame. It is defining that location on the end of arm tooling. So when we're dealing with the tool frame, that is something that we can generate. We can enter in with a manual numeric values. If we know the numbers, the measurement from the center piece of this to this point here, if we know exactly what all those points are, we can enter those in directly. Otherwise, if we don't, we have to. We can actually go out and move the robot to several different positions, which will be illustrated here in a minute, to demonstrate how to get that location defined for the robot. Any questions regarding any of that?
Nope.
So here, using a software called RoboGuide, I was able to extract a couple of points of information here. The default tool frame position, as you can see, is the center of the 6-axis. They put a little ball here illustrating that is the tool center point. And then as you can see here, they give us the Cartesian coordinates X, Y, and Z. If you compare this to the origin of the robot, it would be in parallel with those two. So now what I'm doing here is I'm illustrating the difference between the default location, and now I've added a pointer to the end of the robot, and how it moved that tool center point, or the origin of the tool center point, to the end of that pointer using that same software. And noting again, remember that this tool center tool frame is in parallel with the world frame.
Makes sense.
I just grabbed a different gripper to kind of illustrate the same thing, so I put a gripper in there. Now here, I define the tool center point for this myself again as being the location at which I would be grabbing a part, as opposed to center. So there's several different ways to create a tool frame. Today I'm going to demonstrate the three-point method, which is probably the most commonly used. They offer a 4-point, which is a little more accurate, and then they have direct entry, as I mentioned before, 6-point as well, XY and XZ, excuse me, and XY, as well as a 2-point plus Z. But I think the 3-point is what I've typically used in the past, and that's what we're going to demonstrate today. So without any further ado, I'm going to move over to the robot, and we're going to take a look and see how to go about developing that. So first thing we got to do here is go to menu, go to setup, then we go to frames, this is 7. Then we go to other, which is tool frame, which is, it defaults to that already, so we have tool frame, so we have tool frame. Then we go to type, and we're going to go to frame. We got tool frame 1 selected. I'm going to select a different one so we don't change what we have now. There, that one's not used. Okay, I'm going to use tool frame 4. It's not being utilized at this time. I'm going to enter a value of just say this will be a marker. So I'm just going to call this. I'll just call it 111. How about that?
So if we had multiple tools,
we could have
multiple.
We could have multiple.
Frames.
As you can see, I've got multiple frames. I've got the vacuum, I'm sure, is one.
So
I've got the gripper as another. So that's why I'm sure that's why the first 3 are utilized. Just utilizing that. Also, there's a laser that shoots down the center of this. So I'm sure that's probably a part of those. Now we select the method we're going to use. We're going to use a 3-point method. So by hitting F2 method, we can select that. So let me come in here, and we got to pick 3 separate locations to teach to. Now, it's really nice to have a solid location. So I'm going to try to take this marker and maybe pick a corner or something to choose from as a location. Does that make sense?
Yep.
So here we're going to manipulate the robot to come down here and touch a few points here. Switch this guy to T1 mode here. Switch this guy on. Alrighty, let's see if we can get this thing to do what we want it to do. I'm at 10%, which is a decent speed. Maybe a little bit too slow. I might fall asleep by the time we get there. So the idea behind this is that we come in with 3 different locations. The more drastic we make the 3 positions, the better, the more accurate our information will be. I'm going to switch to world. Try not to bang it around too much here. Does that look like it's about touching there?
It's not too bad. You might want to go back this way just a little bit.
That look good there?
Yeah, I think so.
A little more. It's hard to get all the angles, you know? Okay, let's go ahead and record that position. So we hit Shift, record for the first position. It goes from UNIT or UNINIT, uninitialized, to recorded. Okay, so then we go to we pick the next point. So I'm just going to raise the axis straight up. Speed up again a little bit. I'm going to try to come in at a different angle, so I'm going to bring this guy, I'm going to switch it to join again. I'm going to rotate some axes here. Let's see here. I'm going to go this way. Start on the left-hand side. Let's get some speed going here again. I guess I can go 100% when I'm at T1 here, moving into air positions here.
Yeah.
Okay, then I'm going to go ahead and come this way. Okay, I need to bring that marker around a little bit. Okay, come down this way a little ways. Now let's see if we can find that. Shift back to world. Let her slow it down again. Y plus. Down a little bit maybe?
Were you going off that corner?
Yeah, right off that corner there. That's pretty good.
Close, yeah.
Alright, so we're going to record that location.
So that changes to recorded.
Yeah, so that'll return to recorded as well. So now I've got 2 positions recorded. Now I can also, if I go Z, if I get this thing out of the way here, if I raise this guy right out of the area, it'll let me move to the previous location. So if I hit Shift Move 2, it'll show me where I was before.
Oh, good.
So that's where I was before. So now I can make sure I'm not at that. I got to move it farther forward. So I'm going to go ahead and Z plus this guy. Banged around my tool a little bit, so I probably knocked myself out of whack a little bit. But all right, switch this back to join again.
And then we'll just have to do that last one as
Right.
much after. Okay.
Yep, exactly right. So again, the more sweep we do, the better off we are. So let's see here. We're going to go. Think it'll be all right.
Yeah.
Well, you know, the RoboGuide is you don't realize you're getting into singularity because you're zoomed in on the project you're working on, and you get into singularity all the time. There, it's one of those challenges you got to be aware of. Move it to world. Just shift back to world with coordinates here so I can get fine tune this thing in there a little bit. How's that look there, John?
I think you're pretty good. Go a little bit more. Yeah, it should work.
That should work. Okay, so now this last piece I'm going to shift record. Once it's all 3 been recorded, you get the point that's called used.
Okay.
So now my tool frame, tool number 4, has all 3 points and they're all able to use. Now, so again, if I go Z plus on this guy a little bit, I want to get clear of the, I could actually go back and check each one of those points. I can get the Shift Move 2 and it'll get me back to the first point I taught. So you can see how much movement I have between each point. So you can validate that, yeah, I have a pretty good range of motion
So now
between
it'll
each.
rotate around the end of that.
In theory, it should move around that marker, yes. So if I do make sure, we go to Shift Tool, I have to select tool number 4 now. So I hit Shift Tool, and then hit a 4 here, Enter. So now I'm in tool number 4, and we can validate that by shift coordinates. Tool number 4 selected. So now you'll see how well it's programmed by how tight it holds that position. Now, you're probably going to find that because I moved the block a little bit and I ran into it a little bit hard here in a couple of spots, it's not going to be perfect. And it's very difficult to get it to be perfect, but So here I'm rotating back. It should be holding that marker tight to that surface.
Not too bad.
Not too bad there. No. And then if I rotate this direction, it should be holding that same position. Not too bad.
Yeah, looks pretty good.
Staying right there, isn't it?
Yep.
It's not bad, is it?
No.
It's pretty good. So that's the.
That's actually easier than when you read it.
Yeah.
When you read it, you're like, there's a lot to it.
There's a
but
lot of
to
steps
do
to
it.
it.
It's
Yeah,
not,
it's
not
not
that
so bad
bad
at all. So.
Cool.
So yeah, it's a pretty easy process. Again, a couple key points is to make sure when you're done, you have all 3 points saying used. That lets you know you're used. The other component you got to make sure is you select the correct tool when you're operating using that tool frame that you created. Because again, if I would have stayed in tool 3, it would have had a complete different response had I done that same process. It wouldn't have kept that marker on that surface. So we're right there on that, maintaining a pretty good piece on that. So pretty happy with the results there. Better than I was anticipating anyways. Okay. I just moved my marker again, but a little bit anyways. Okay, so that is how we develop a tool frame. I mean, like again, there's multiple different ways to do the same thing, but just to recap on that, we go to Setup, Frames, and then from there we have Method, and we can select which frame we're going to modify. So again, I hit 4. So here to create the next one, you'd have to go to a 5, say. So we can see there's no data here, it's not being used. We could create, the first thing we do is we create the name again. So here you actually do a little bit of that. Go ahead and comment on that. Okay. So next step is method. Yep. So then we go to 3 point, just hit enter for that. Yep. So go down to first teach point. Now go ahead and teach your first position. Go to, you want to go to world at this point, or join, excuse me.
Oh, okay. Oh,
there you go. Get you down to join, then switch to world as you get close. That's the way I typically will do it. It helps get us. Key point here being making sure you're hitting that same point on all 3 angles there. I know usually it's a lot easier with a pointer, but we're just doing edge to edge.
And then I need to record.
Shift record, yep. Okay. We're doing
a little close there.
It's easy to get those buttons all mixed up. I want to get close. I usually switch to world. That seemed to help a little bit. So now you're focused not on the joints that need to get you there, but the actual direction you need to go to get there, which is a little easier, I think.
I think it was right about that corner.
That's pretty good.
I'm gonna go with that. Record that.
Okay. All right. Takes you right to that position. Ain't that nice?
I got lucky.
Yeah, clear. I didn't get, so I hit it when I did the same thing. So.
Record there.
Okay. Now go ahead and hit go to the coordinate system and select tool number 5. So shift coordinates. Now put a 5 in there. Enter. So now you're on tool 5.
So that's the one I just taught.
Yep. So now you want to see if you can do the minor axes. See if you can get those to rotate around that axis that you just created, the tool center point you just created. So
Looks like it.
sure does. Looks really good.
Yeah, because I kind of use that edge right there and it's not
Yep.
floating, so.
Yep.
All right,
Nicely done, John. Very good.
thanks.
So yeah, it's that's how to develop a tool center. They also call it TCP, and used again in material handling. It's used in laser cutting, laser welding, all sorts of different applications. So for different end of arm tools, you can have for the Fanuc, you can have quite a few different tools to select from, and there's certain models that even let you have more. But, yeah, that's the tool frame. Different ways to create it. Again, I threw in some more videos here of well, actually some pictures of what I was following here was I did a demonstration of X plus, X minus, Y plus, Y minus, and then Z plus, or Z plus and Z minus. Just it recorded some locations where that tool center point ended up in that location. So that was my observation there. So the next piece will be user frame.